Okay, welcome back, students. So let's continue the bungee jumping. So first of all, he goes up on a high bridge. So the person he want to jump, he goes up on a high bridge. So what is the gravitational potential energy? It's the energy stored in a body when his position change with respect to the reference. What the meaning of with respect to the reference? What is the reference? It is the ground. So if any object is lifted up, it will gain gravitational potential energy. So when the person goes up on a high bridge, so he gain GPE. What is a GPE? Gravitational potential energy. So after he attaches a strong elastic cord to his leg and he jump off and start to speed up, so the gravitational potential energy changed into kinetic energy. When he jump and he start to speed up, so the speed increases, so the gravitational potential energy is converted into kinetic energy. So the kinetic energy increase and the gravitational potential decreases. Why the gravitational potential decrease? Because the height of this person decrease. When the height of this person decreases, the gravitational potential energy decreases. So why the kinetic energy increase? Since the person is speeding up, so the speed increase, so the kinetic energy will increase. Okay, after this step, what will happen? Okay, eventually the bunch cord is straight and start to stretch. Now the next step, the bunch cord is straight and start to stretch, to elongate. So the kinetic energy changes into elastic potential energy. In this step, the kinetic energy, it converted into elastic potential energy. Yani the speed of the kinetic energy decrease with the increase of the stretching of the spring. So if the spring, the stretching of the spring increase, the speed will decrease. When it reaches the maximum stretching, the speed approximately is equal to zero. So let's continue. So the kinetic energy changes into elastic potential energy. Since the elastic cord start to stretch, when it reach, and be careful, it's an important point, when it reaches the maximum stretching, so we reach the maximum elastic energy. So when it reaches the maximum stretching, this is the maximum elastic energy and the minimum kinetic energy, because the maximum stretching, the speed is equal approximately to zero. So write it as a note. When the maximum elastic energy, when the elastic energy is maximum, the kinetic energy is minimum. So the speed is approximately zero. So write it as a note. The cord will stop moving for an instant, for a specific instant. Maybe it's 0.00001 second. Okay. The cord will stop moving. So this is the maximum stretching. So the kinetic energy is equal to zero in this case. Okay, is it clear? Now, storing energy in materials. Okay, we discussed before that when materials are stretched or compressed, their shape changes. We say that they deform. What the meaning of deform? That the shape changes, compressed or stretched. When they deform, they store elastic potential energy. So when we compress or stretch any object, of course, it will store elastic potential energy, which is E.P.E. When a ball hits the ground, it deforms. And look at the picture. Okay, when a ball hits the ground, it deforms. So its kinetic energy at this instant change into elastic potential energy. But when it's changed the shape, only when the ball changed the shape, so there is a deformation of the object. So the ball store elastic potential energy at this instant. Okay, so let's study the steps of the bouncing ball. So, what are the energy changes when a ball bounces? First of all, if I want to throw a ball, okay, what are the energy changes when a ball bounces? First of all, a ball falling transfers the gravitational potential energy into kinetic energy. And we discussed it before that any ball I throw a ball, I release a ball from a height, the gravitational potential energy start to convert into kinetic energy. Okay. When the ball hits the ground, which is part two, step two, okay, its shape changes and the kinetic energy is transferred into elastic potential energy. So when the ball hits the ground, look at the shape change. Compare the two shapes. The shape of the ball changed. So uh, it stored elastic potential energy. So the kinetic energy is transferred or converted into elastic potential energy. Now, step three, as its shape is restored, the elastic potential energy change back into kinetic energy. So the ball will come back in the opposite way. So the elastic potential energy will change back into kinetic energy. Why? Because it hit the ground and it will come back up. And the last step, as the bouncing ball gets higher in the air, kinetic energy is transferring back into gravitational potential energy. So when it go back higher, so the kinetic energy is transferring back into kinetic energy. That it will slow down to reach its maximum height. We explain it later. So when we reach a maximum height, the speed at this point is zero. So maximum gravitational potential energy, minimum kinetic energy, and then it will repeat the four steps. Okay, now be careful when the ball bounces back up into the air. It's the last step. Okay, the last step, when the ball bounces up into the air, it does not go up to the same height. So it will not reach the same height. It will reach less height. And you know that, and we perform it in the lab as an activity. We do it as an activity in the lab. You of course you remember. So which each of the above transfer of energy, some of the energy is wasted as a heat. So why it reach less than the first height? Because some of this energy is wasted as heat, thermal energy, as a thermal energy. Why? Because of the particles of the air. It's a kind of friction, and friction produce heat. You all know